Alright, today's lesson is about just solving and using either method. We can complete the square, we can factor, we can use the quadratic formula, or we can also just solve it by taking the square root if it's already set up. So let's say it's already set up where you can just solve it. Those are like the four ways you can do it. So let's look at this first one. This is actually one we talked about yesterday. Let's get everything over to one side. You always want to set it equal to 0 first just to look at it. We get 2x squared minus 12x plus 18 equals 0. Again, if you can cancel anything out when you're solving, factoring you can't cancel, but solving you can. I'm dividing everything by 2, and I get x squared minus 6x plus 9. This is factorable, so I'm going to solve by factoring this because it's easier. When I factor this, I get negative 3, and negative 3 gives me a positive 9. So it actually turns out to be this. I just factored it, and now I can solve. X minus 3 has to equal 0, which means x has to be 3. And again, there's only one solution for this one because the 0 is a double 0. Alright, so I used factoring for that one. Again, use factoring first if possible. Let's look at this next one. This next one, this is where we say we're going to take the square root. Because look, it's already in a form where if we took the square root to free this up, we're good. However, we have to first isolate that. So we have to get rid of this negative 4 by dividing. So we get the quantity x minus 7 squared. So this is factoring, I should write. This is taking the square root. On the test, there is a section where you have to use only one method. You can only use each method once. So it's good to know all the methods because then you will have more skills on solving all these things. So I have this. Now I can take the square root. So if I take the square root, I get x minus 7 on this side. I get plus or minus, and then the square root of negative 25. Well, the square root of 25 is 5. But since it's negative, we have an I also. So we have 5i. So my final answer for this problem is x is equal to positive 7 when you move it over, plus or minus the 5i. And that is it. Alright, so we took the square root. Now let's see what we can do here. I'm going to put everything on one side first just to see what happens. Okay. This is actually a good one, since we can't factor this, 5 and 1, and that's it. This is a good one to try taking the square. Completing the square. Because, here's when you know to use completing the square versus quadratic formula. To complete the square, you have to have the middle number and then square it. Well, what's half of 2? It's 1. 1 squared is 1. So it's an easy number to work with. So, I get x squared minus 2x, and then half of that is 1 plus 1. And I get plus 5 minus 1 equals 0. Alright, so I completed the square, so this can be written as x minus 1 quantity squared. Over here, this is a net of a positive 4, so I would move that over. I'm going to subtract 4 and put it over here. Negative 4. Now this becomes a problem just like number 2. Now you would be taking the square root. However, this is called completing the square because you have to do that first. The reason being, you get it to this point where now you can take the square root. Now we're going to take the square root and get x minus 1 is equal to positive or negative. Square root of negative 4 is a 2i again. And finally, x is equal to 1 plus or minus 2i. And again, if you would have taken or used the quadratic formula, you could have gotten the same thing. Alright, this one here looks like a factoring one to me. So we're going to factor this again. So we're doing a factoring. And this looks like a difference. So there's a subtraction symbol between two different things being squared. So the square root of this is 4x. Square root of that is 3. And then the pattern says that we have to have the conjugates in order for that middle term to cancel out. So I have factored it. I get 4x plus 3 equals 0. 4x minus 3 equals 0. and then I can go about solving. So x equals negative 3/4 and x equals 3/4. Okay, so those are my two solutions. Finally, we're going to have to do kind of a combination here, actually, because notice how we have x cubed, x, and x squared. We can't do anything with quadratic formula with an x cubed. So just to make this easier, let's get it all over to one side. And let's cancel out anything we can. Can we do 4? No, we can't. We have to do 2's. So let's divide by 2. So I got 9x cubed plus 6x squared minus 4x. Now I have to factor. I can take out an x out of everything. Okay? You can try to see if this is factorable, but I don't think this is. So let us now, for this piece right here, use the quadratic formula to get that solution. Because what we have here is you set each piece equal to 0. So we're setting this big piece equal to 0 and x equal to 0. So one of our solutions is x is going to be 0. And we should get 3 solutions for this problem because it was x cubed. Now we also have 9x squared plus 6x minus 4 is equal to 0. Here's where we would probably use quadratic formula, because to pull out a 9 out of both of these, you're left with fractions. Completing the square is not fun. So let's use quadratic formula. X equals opposite b plus or minus the square root of 6 squared minus 4 times 9 times negative 4 all over 2 times 9. So we get x is equal to negative 6 plus or minus. We get 36 plus another 36 times 4. So that should equal 180, square root of 180. All over 18. Okay, so now we have to break down this, what am I trying to say? This radical. 18 and 10. We can do, what can we do here? 16, or 6 and 3. Okay, and then we get 5 and 2. Alright, so if I break this down, I have a pair of 3's and a pair of 2's. So that's going to net a 6 outside. So I get x is equal to negative 6 plus or minus 6, and then I'm left with a 5. We can break it down and simplify, and we get x is equal to negative 6/18 plus or minus 6 root 5 over 18. And we can simplify these fractions to be x equals negative 1/3 plus or minus root 5 over 3. And that's our final solution. And that would be using the quadratic formula. So, and factoring, actually, I use both, but you have to factor to get it down to a quadratic formula part. Okay, so that is using all the different methods on solving these problems. Very important on solving quadratics, all the different methods that we have here. Okay, so let's do a word problem. Quadratic models in real life. So we have object being dropped. We actually did one of those already. And then we have object is thrown or launched. Okay, or tossed or lobbed or whatever you want to call it. If it's being tossed or thrown anywhere, you have to use this one. Okay? Where, again, HO is your initial starting height, H is your final height. In this second equation for the launching or throwing, VO is your initial velocity, HO is your initial height. And this is all feet per second. If you are throwing it upward first, your velocity is positive. If you are throwing the object towards the ground already, your height's changing faster, your velocity is negative. If you throw it straight parallel to the ground somehow, then your vertical velocity would be 0. You don't actually have a vertical velocity, and gravity is the only thing pulling it down. We're talking about vertical velocity here. So the tallest building in the United States is in Chicago. It is 1,450 feet tall. How long would it take a penny to drop from the top of this building. All right, so we're doing a drop. So we're going to use that drop model. Our initial height is equal to 1450. So I say my final height is 0. So I'm going to set up my equation to be 0 equals negative 16t squared plus, because we start above ground, 1450. This is one where you could just solve using the calculator. We get negative 1450 equals negative 16t squared. Divide by negative 16 and solve. You get t squared is equal to 90.625. Take the square root. The time it would take would be about 9.52 seconds. Again, that is if there is no wind resistance or anything, which obviously there is, so it might not be exactly that, but we're using it assuming that. So it will take that long. How fast would the penny be traveling when it hits the ground if the speed is given by s is equal to 32t, where t is the number of seconds since the penny was dropped? Well, this is just a plug-in problem now. All right, we know what the time is that it took to drop. So the speed at which it is hitting the ground with is 32 times 9.52, which is about 304.64 feet per second. Now notice how I said speed. Speed is just the magnitude. There's no negative signs in speed. If I asked for the velocity, though, velocity is given in direction and magnitude. So the velocity would technically be negative 304.64, because that would tell me that it's going down towards the ground at that point. But since I only asked for speed and I gave you an equation for it, you're good to go. All right, final problem. The water in a large fountain leaves the spout with a vertical velocity of 30 feet per second. After going up in the air, it lands in a basin 4 feet below the spout. If the spout is 10 feet above the ground, so here's the spout, 10 feet above the ground, how long does it take a single drop of water to travel from the spout to the basin? So the basin is 4 feet below the spout, which means it is 6 feet up above, right? The ground. Here's the ground. And here's the fountain. It's going and hitting there. Okay? So let's think about this. We're doing the tossing, throwing equation. So if we look back up here, negative 16t squared plus VOT plus HO. So my final height, though, is not 0 in this case. So H is equal to 6, HO is equal to 10, VO is equal to 30. So I'm going to plug in all my numbers. 6 is equal to negative 16t squared plus 30t plus 10. Now at this point, if you want to use your calculator to solve this, usually with word problems we're okay with that, you could plug this into your y2 and this into your y1 and fix your window and see where they intersect. Okay, so let's look at that real quick. Okay, so here is the graph with that stuff inputted and my window going from like 0 to 100 in the y and like 0 or negative 3 to 3 in the x. That's the window I got to see this thing. This line here is the line y equals 6. So we want to know when it hits y equals 6 over here. Obviously, we're not going to look at the 1 negative because that won't make any sense. We're only looking at the positive answer. So I'm going to go to the intersection point. I'm going to hit down to get onto the horizontal line and move over towards the intersection point. And finally, we're going to hit enter 3 times once this arrow stops blinking. All right, 1, 2, 3. Okay, at a height of 6, the time is 2 seconds. So the drop of water will take 2 seconds to hit the ground. So let's look back at our problem then. So on my graph, it wouldn't hit the ground actually, it would be at 6. So here's 6, here's 10. This point here is 2 comma 6. So t would equal 2 seconds. Okay? Alright, so that is using your calculator again to solve it. Otherwise, you could have moved the 6 over, set it equal to 0, taken out or tried to factor it, or you could use quadratic formula or completing the square, any of those methods to solve it by hand. Okay? Alright, and that is it.